So now I take that second derivative and I set it equal to 0, and I continue to simplify that expression. I noticed from the previous step that there was an x squared minus 4 in the numerator, and there was an x squared minus 4 to the 4 in the denominator, so some division can occur. I've also done a little bit of expanding, and now I end up with 0 is equal to 2x times negative 3x squared plus 12 plus 6x squared plus 24, it's all in brackets, and then that whole thing is divided by x squared minus 4, which is all cubed. Combine my like terms in the next step, and I end up with 0 is equal to 2x times 3x squared plus 36, and that's all being divided by x squared minus 4, which is all cubed. And then I notice that I can common factor a 3 from the binomial in the numerator, and I'm left with 0 equals 6x times x squared plus 12, and then that's all divided by x squared minus 4, which is all cubed. So remember that points of inflection occur when g double prime does not exist, or when g double prime is equal to 0. So in the first case, I'm going to look at g double prime x where it does not exist. Well, it will not exist when x squared minus 4 equals 0. When I solve that, I get that x is equal to 2, or x is equal to negative 2. It's important to note that these were our vertical asymptotes that we identified at the beginning of the question. These values of x are not in the domain of our function, and therefore they will not be considered when we're trying to determine points of inflection. In the next case, we've got to consider where g double prime of x equals 0. So we want to set the numerator equal to 0. 0 is equal to 6x times x squared plus 12. And therefore, in that factored form, we know that either 6x equals 0, which gives me x equals 0, or x squared plus 12 is equal to 0. When I try to solve that resulting quadratic using my quadratic formula, you'd find that there's no real solutions. You didn't have to use the quadratic formula. You could have also just said x squared equals negative 12, x equals plus or minus the square root of negative 12. So there are no real solutions. So after I've got that x is equal to 0, I find the corresponding y coordinate by substituting back into my original rational function, and I find that y is equal to 0. So we've got the point 0, 0. Is it a point of inflection? Well, we're not sure at this point in time. So what we do is we put down our number line, and in this case we now have to not only include the x value of 0, our potential point of inflection, but if you remember, we identified our vertical asymptotes at the first part of the question. So we must also consider those values and place them on the number line, because as we previously mentioned, concavity can change across those vertical asymptotes. So now we're going to test g double prime x at x equals negative 3, x equals negative 1, x equals 1, and x equals 3. These are x values found in my 4 different intervals found on that number line that I just drew on the left-hand side. So when x is equal to negative 3, I find that g double prime of x is equal to negative 378 divided by 125. So I place a negative there in that region of my number line. When x is equal to negative 1, my corresponding value for g double prime of x is 26 divided by 9. So I place a positive in that interval. When x is equal to 1, my corresponding value for g double prime x is negative 26 divided by 9. I place a negative on that region of the number line. And when x is equal to 3, my corresponding value of g double prime x is 378 divided by 125, so I place a positive on that portion of the number line. Now we've done all the work, we just merely have to make our conclusions. We know that a function is concave upwards when its second derivative is positive. Therefore, it is concave upwards when my x values go from negative 2 to 0 in union with values between 2 and infinity. It is concave downwards when my second derivative is negative. Therefore, it's concave downwards when my x values go from negative infinity to negative 2 in union with values between 0 and 2. And we now know that the point 0, 0 is indeed a point of inflection because concavity changed across that particular point.